Welcome to our first video lecture for the first unit in chemistry. Unit is entitled Tools of Chemistry. In this unit we'll be looking at some of the basic ideas and concepts that we'll be dealing with all year in this chemistry course. The topic of this first one are the SI units and prefixes. And we have three different learning targets here for this lecture. We want to define the 7 SI base units, quantities, and symbols, explain what a prefix does to a unit, and then define the SI prefixes from pico to tera. In this section here, you'll see a list of resources. First of all, you can see the text pages that you will find this information in. We will be referring to a couple of tables in your text in this lecture, so you might want to have your book handy. A couple of practice worksheets that you can find online at these websites here. And then this link here for video is actually a playlist on YouTube. I'll be referring to it later. There's a lot of good stuff there. All right, so first of all, I'm just going to ask the question, what does SI stand for? Well, SI is really, it stands for the International System of Units. International System of Units, and it's commonly referred to as SI. It is a standard system. It is a standard system that is universal. It is used in science across the entire world, and it gives scientists a way of communicating with each other very easily because they're all familiar with this same unit. In the SI system, and really the basis of all the SI system, are the 7 base units. There are 7 base units in the SI system. Base units. These are a defined unit. Defined unit based on an object or event in the physical world. So these 7 base units, which we'll throw up here real quick in a table, they are all defined. In other words, we know the value of the base units based on something that exists or happens in our world. And that is what all the other units come from. You can find a list of these 7 base units on table 2.1 on page 33 of your text. 33. And you need to memorize these. Okay, there aren't too many things that you'll need to memorize in this class. Actually, very few. But these I would like you to memorize just because we deal with them so often. Here is that table. I want to show it to you here. Here, table 2.1. It gives you these 7 SI base units. You can just count them there. And you can see what is being expressed here. We have the quantity. So the quantity is what we're measuring. If we're going to measure time, the base unit for that in the SI system is the second. And the symbol for that, you might think of it as the abbreviation. We call them symbols in science. That's the lowercase s. So you can go through and see each of these base units. A base unit for length, mass, temperature, etc. So what you need to memorize, you would need to memorize everything in this table. So for example, if I asked you, what is the base unit for temperature? You would need to know it is the Kelvin, and the symbol is the capital K. Likewise, I could say the candela, or sometimes pronounced candela, you would need to know that as the base unit for luminous intensity, and its symbol is the lowercase cd. So spend a few minutes working on memorizing those over the next few days, and you'll have those down. So there's these 7 base units. And the video link that I gave you up here under the resources, there are 7 videos actually on this playlist dealing with each individual with the 7 base units. And it talks extensively about the standard by which each of these are defined. Just to give you an example, probably the easiest one is our standard for the kilogram. There is an actual metal alloy that's kept in under very high security in France. And the mass of that alloy, it's made of platinum and iridium, I believe. The mass of that alloy is defined as 1 kilogram. And all other kilogram weights, if you will, are just simply replicas of that mass. And that is how we get the definition for a kilogram. The definition for the second is actually based upon the speed of light and how it travels. The meter is defined, I say second, I meant meter. The meter is defined as the distance that light will travel in a vacuum in 1/300 millionth of a second. It's actually like 1/299,800 something thousandth of a second. I don't remember what it is off the top of my head. But there's each of these 7 base units has a physical event by which they are defined. So the question I want to ask now then is, are there only 7 units in the SI system? Are there only 7 units? Well, if you go back and look at that table again, I'll throw it back up here. These are 7 units, some of which I know you're very familiar with, the second and the meter and the kilogram, maybe the Kelvin, maybe the ampere or amp for short. Probably not so much at this point the mole or the candela. But there are many, many other units as well. But those aren't base units, because those are all combinations of these base units that we have here. Just as an example, for example, let's say we wanted a unit for the speed of your car driving down the road. The unit you might use might be meters per second. Notice the meter and the second are both base units themselves. When we combine them by taking meters over seconds, we get a unit for speed, which works well. Now, it's not a base unit because there is no definition for that, but the units that make it up are a base unit. If you wanted to measure the volume of something, as far as in terms of base units, that would be meters cubed, because you take meters times meters times meters, 3 dimensions, that would give you meters cubed. Again, meters cubed is not a base unit, but it's a combination of base units. In this case, meters times meters times meters. Another example of one would be a unit for force. In the SI system, the SI unit for force is the Newton, which is, the symbol is the capital N. And that is actually equal to a kilogram. Notice that's a base unit. Times a meter, which is also a base unit, divided by a second squared, which a second is also a base unit. So we can see how all of these units here are all made up of base units. Any unit that is a combination of more than one base unit is called a derived unit. It's called a derived unit. Okay, so all these other units, and there's hundreds of other units other than the 7 base units. All these hundreds of other units are all derived only from these 7 base units that have been defined in the SI system. All right, so that's kind of the unit part of it with our first learning target up here. The next part of this lecture here, we want to look at SI prefixes. And the prefixes are all based on the fact that the SI system, it is a decimal system. What we mean by the fact that it is a decimal system, it is based on powers of 10. Powers of 10. It's all based on powers of 10. So what that means then is all these prefixes are all different powers of the number 10. Just as an example, before we get to all the prefixes, there's a table on here in your book that'll show you. Say we had a meter stick. Okay, and here's our meter stick. I'm going to draw out a meter stick. And this is 1 meter. 1 meter. That's what we have here. And say I was going to use this meter stick to measure your height. Now, that would work pretty well. Most of you are going to be somewhere between 1 and 2 meters tall. In fact, unless you're like 6'5", you're not going to be any more than 2 meters tall. So we could use a meter stick pretty easily in order to measure you. Okay, we'd need a couple of them probably, but we could make that happen. But say you're going to measure something a little smaller. I don't know, like the height of a peanut butter jar. Okay, a meter stick might not be so convenient because it might be too large to do that. But if we use a prefix, we could actually change the unit slightly in order to make it easier. Okay, a unit smaller than a meter, if we take this and divide it into 10 equal parts, I'm going to try to do my best here. If I divide it into 10 equal parts, 2, 3, 4, 5, 6, 7, 8, 9 lines, that's 10. I'll say those are all 10 equal parts. So now each of these represents 1/10 of a meter, so 0.1 meters, which is equal to a decimeter. The prefix deci in the SI system means 1/10, or 10 to the negative first. And I could use that smaller unit in order to take a measurement. Now let's say I took this part, this 1/10 of a meter, this decimeter, and I blew it up. Okay, I'm just going to draw the same thing I had here before, but we're going to say this whole thing now is 1 decimeter. So this is 0.1 meters. Here's what we have here. And I wanted to measure something even smaller, say like the thickness of your finger. This might be too large. So again, I could divide it by tens again. I'm going to divide it into 10 equal parts. Again, those are supposed to be equal. And now I have 1/10 of 1/10, which would be 100th. 0.01 meters, which is equal to a centimeter, because in the SI system the prefix centi means 100th, or 0.01, or 10 to the negative second. And I could keep doing this. I could keep dividing it by 10 as much as I wanted. I could also go the other way. I could multiply by 10. Okay, say I wanted to measure the distance, instead of measuring your height, I wanted to measure the distance from Lake Mills to Joyce, or Forest City. You wouldn't want to use a meter, because that it wouldn't make any sense. There would be way too many meters there. So we'd want a larger unit. So let's take a look at all these prefixes here. This is also in a table in your book on the same page actually as the previous one we looked at. This is table 2.2 on page 33. And this lists several of the SI prefixes. Now this is not all of them. There are actually several more that are not on here, and you can see I've had students in the past add things to this, and I'll tell you to do the same if it's not in yours. You can see here, starting in the middle of this table, with no prefix, that just means we're talking about a single value of the unit. So 1 meter, 1 liter, 1 second, doesn't matter. Power of 10 equivalent being 10 to the 0. As you know from math, anything to the 0 power is 1. If I want to make the unit smaller, I can use these prefixes down here. I can see that the prefix deci means 1/10, or 0.1, or 10 to the negative first. Centi, 0.01, 10 to the negative second, etc. And this table goes all the way down to 10 to the negative 12th. SI prefixes actually go down to 10 to the negative 27th, if I remember right. Now, they're not shown on this table. They're not very common. We don't need them very often, so we don't need to worry about those. If I want to make a unit bigger, I can use something up here. And notice here I've had a student add something here. The prefix deca is not on here, so if you can add that if you want, if it's not on your book. The prefix deca, which is D-E-K-A, has the symbol D-A. It means 10, or 10 to the first. Kilo, the reason this has changed here is your book has a capital K for the symbol. It's not a capital K, it's a lowercase k. It means 1,000, or 10 to the third. And you can see this goes here up to 10 to the 9th, or a billion. There is another one I'd like you to add here. You can see this student's written it over here. It is the prefix bigger than giga. It is the prefix tera. The prefix tera has the symbol capital T. It means a trillion. So that's 1, as you can see there, followed by 12 zeros. And has that would be 10 to the 12th is what that would be. Thus the 12 zeros there. These you need to memorize as well, okay, including the ones that I've shown you here that have been written in. If you have questions about those, please just ask. Okay, so I'll jot this down here on your notes. So these are all listed in table 2.2 on page 33. Okay, and we want you to memorize these. Okay, these we will use a ton in this class. So it is important that you get those memorized here fairly soon, actually. So I'd be working on that if I were you. Okay, so what I want to do now is just to give you some examples of how it is that these prefixes work. Okay, just a few basic examples here, and that will end the lecture. All right, so say we had, say I told you we had 1,000 meters, and I want to know what that would be equal to. Well, the prefix 1,000, the prefix that means 1,000 is kilo. If you look on your table there, you can see that kilo is equal to 1,000, so this would be equal to 1 kilometer or a kilometer. That's usually how we would pronounce it. Oh, sliding off the page here. Get it down here so you guys can see it. So that's how we'd use those prefixes. Okay. Likewise, if I had, let's say I had 0.0000001 liters. Okay, this is 1 millionth is what this is if you count it out. 10th, 100,000th, 10,000, 100,000th, millionth. The prefix that means 1 millionth, if you look on your table there, is the prefix micro. So this would be 1 microliter. The symbol for the micro is a Greek letter mu. It kind of looks like the letter U, but with a tail on the front of it. That's what that letter is. So we can see how these prefixes might work. Now what about this? Let's say I had, 1 megasecond. 1 megasecond. I want to know how many seconds that is equal to. Well, the prefix mega, if you look on your chart, means a million. So this would be equal to 1 million seconds, or 10 to the 6th. 10 to the 6th. Or say I had 1 nanosecond. 1 nanosecond. If you look on your table there, nano means a billionth. And nano means a billionth. So this would be equal to a billionth, which is 10 to the negative 9th seconds. That would be, if you wanted that in decimal form, it would be 0.000000001. That's 8 zeros followed by a 1 there is what that would be. Okay? Now what if I had this? Let's say I had, how do I want to ask this? I want to know how, let's say I had 1 meter. Let's go back to meters. I had 1 meter, and I want to know how many kilometers that is equal to. Okay, 1 meter equals blank kilometers. Well, we know that kilo, it means 1,000, if you look on your chart there. This does not, however, mean that there are 1,000 kilometers in a meter, because kilo is bigger. Okay, a kilometer is 1,000 times bigger than a meter, because kilo means 1,000. So while kilo means 1,000, there would be 1,000th, or 0.001 kilometers in a meter, because there are 1,000 meters in 1 kilometer. If you look back here that we wrote over here. Okay, so we have to think which unit's bigger, and we don't want a bigger number with a bigger unit, because that obviously wouldn't be the case. All right, one more example here. Let's say I said I want to know how many, I have 1 liter, and I want to know how many deciliters. How many deciliters are in that? If you look at your table, you'll see that deci is 1/10, or 0.1. So 1 deciliter is 1/10 of a liter. So in order to equal 1 liter, I'd have to have 10 of them. 10 of them. Okay, if this idea here is confusing to you, it is not something that is readily apparent right away to many students. Don't worry about that. We'll be dealing with it a lot in class. The important part at this point is you get those prefixes memorized, and then once you have that, this stuff will start to fall in place, as we'll work on quite a bit in class. All right, that ends the video.